Thank you all for coming. We're going to talk today about the platform for future AI. But more importantly, what I'm going to do is really set the stage for the upcoming talks. You're going to hear from builders that are using Cerebras systems today to accelerate time to insight, time to new capabilities across industries. But honestly, before I get started, once again, I want to thank you all for coming. And moreover, I'd like to thank Julie, wherever she went, as well as the Cerebras marketing and events team for pulling us all together in this extraordinary venue. So if you would, please give a hand to the Cerebras team and the events team for that. We don't always look this good. So let's jump right in. At Cerebras, we have a fundamental hypothesis that I think many of you share. In fact, I'd be willing to bet that all of you share this, that AI has transformative, positive potential, not just for enterprise, but also for science and society. Whether you're developing a new chat application, an app for your retail business, doing drug discovery or finance, energy, environment, climate, all industries will be touched by AI, and I, for one, believe that there's massive positive potential that we can harness together. Here's the problem, is that our ability to innovate, this community's ability to innovate, remains fundamentally limited by the compute resources that we have access to, right? It takes weeks or months, maybe even longer, and massive investments to build new foundation models, let alone iterate upon them. And once we have these sophisticated capabilities, right, you see the pinwheel of death when you ask a question, right? It takes seconds or minutes sometimes to respond when we know from the entire history of the internet that every millisecond matters. So this is just too slow, right? And I think we all know this. Legacy chips and systems, they simply can't keep up, not only with our questions, but with human innovation, right? So we need a fundamentally new compute solution for AI. And of course, that's where we come in, where we believe we have a central role to play. Cerebras was founded in 2016. You're all familiar with us, otherwise you might not be here. But we are an AI hardware and services company. Our team has built a revolutionary new chip and system to accelerate AI computation, both on training and inference, literally by orders of magnitude beyond what's possible with legacy general purpose chips. So why would we go about doing this, right? The fundamental observation that we had is that AI needs something different, right? In particular, AI needs bigger, purpose-built chips because, number one, the status quo is suitable, but not optimal. AI is not graphics. AI is not database or web serving, right? The chips and the systems that do those quickly and efficiently are extraordinary at that. But they're not optimized for AI. They're not the right platform for the future of this extremely valuable and different work. And as it turns out, of course, industry leaders agree, right? Even Jensen Huang, the CEO of NVIDIA, industry leader, luminary, says we need bigger processors. We agree. But why is bigger better, right? Why is he saying that? Why are we saying that? The fundamental observation there is that AI is a problem of massive computation with data in motion, right? So you need a lot of compute resources, but you also need those compute resources to be close together so that they can share data, and also close to their memory, right? So they can access their neurons, combine that with input data, and quickly write it out. And not all chips were built for that. But ours was. So at Cerebras, the centerpiece of our technological innovation and the foundation for our computer systems and our product is a new processor for AI that we call the WaferScale Engine. This is it in its third generation. As you can see, it's quite a bit larger than traditional chips that might be the size of your fingernail or a postage stamp. This is the largest and most powerful AI chip in industry, bar none. Thanks. It's a testament to our team and decades of innovation and engineering. It's about 30x larger than the largest GPU, as shown on screen there, to scale the NVIDIA B200. Right? And we didn't do it because big is sexy or because big is easy. We did it because AI computation wants bigger chips. This is 900,000 cores on one device, 125 petaflops of AI compute on one device. All those cores are interconnected not over meters of optical cable and fiber and copper, but over nanometers and silicon. And each one of those 900,000 cores has its own associated SRAM, all SRAM on chip, that's all just one clock cycle away. So literally 3 to 4 orders of magnitude more communication bandwidth and memory bandwidth, and a cluster worth of sparse AI compute all on one chip. This architecture, while we might not all be chip architects, most of us are users, right? This chip architecture enables a fundamentally different level of performance for AI work. A few years ago, if you knew us, we were building those chips, and we were delivering 1 or 2 of those systems to big customers doing big things in AI. We are now regularly building clusters of tens or hundreds of these WaferScale Engine-powered machines. These are multi-exaflop AI supercomputers that are leading the world in AI computation. They're the compute equivalent, each one, of thousands to maybe even tens of thousands of contemporary GPUs. And one of the unique things that we'll talk about in these systems later, not only are they extraordinarily fast, but they're easy to use. In traditional systems, programming a large cluster of many small chips turns AI into a distributed parallel programming problem. So rather than focusing on AI, many users have to focus on remembering how to use OpenMPI or how to program a supercomputer. With these systems, you can harness the power of an AI supercomputer with the programming simplicity of a single desktop machine. So we deliver these machines, as extraordinary as they are, as a complete and ready-to-use appliance with push-button programming simplicity and the ability to deliver the fastest inference in the industry, bar none. So what is the value, then, really, of these systems, right? Let's put a couple of big numbers up on the screen. Right? These systems in industry today, and with our partners that you'll hear from in a few moments, are delivering training times to state-of-the-art models that are 10 times faster than GPUs, delivering generative AI inference to open the door to new applications that are 20x to 70x faster than what is strictly possible with GPUs. In the world of physics-based simulation for things like high-performance computing, think computational fluid dynamics, think molecular dynamics for drug discovery, materials science, and energy, literally hundreds of times faster than even the world's largest supercomputers. And all of that performance, because our architecture was built for this work, at 3x or better power efficiency. So we're going to talk now just very briefly a little bit about inference and a little bit about training, and then I'm going to hand over the mic to some of our partners that are doing the real-world work that makes us so proud to be infrastructure and tool builders. On the inference side of the equation, right, this is where AI models return value. right? You've trained a model, you're putting it out into production inference so that it can give you answers that it was trained to give you. On the AI inference side, AI inference is a memory bandwidth problem, right? It's memory bandwidth hard. And the reason for that is, every time you ask a generative AI model a question, for every new, let's say it's a language model, for every new word it produces, it has to compute the entire model. And on a GPU, what that means is for every word it outputs, it has to read and write every single layer of the model back and forth from HBM memory to its compute, literally over a thin wire. Right? So it's a lot of stress on this thin wire. And for that reason, generative AI inference on GPU is strictly limited by the memory bandwidth of the physical device that's in the data center. And a device like a B200 has a memory bandwidth of about 8 terabytes per second. Right? This is state of the art. But it's limited by that performance. Our machine, by comparison, has more than 3,000 times that memory bandwidth. And what that means is that the Cerebras system can deliver a fundamentally different level of performance for inference than is possible with a GPU. This is what that looks like in a graph. On the bottom left here is, think of this as inference performance before Cerebras. State-of-the-art models from state-of-the-art providers using GPUs as a compute infrastructure typically deliver output speeds in tokens per second of several tens to, in some cases, hundreds of tokens per second for a user. So that, as a user, that's the output you see when a language model is writing out its response. Right? It's pretty fast, but it's fundamentally limited by the HBM or the memory architecture of the GPU. With Cerebras, even some of the world's most sophisticated models, like Perplexity's model for AI search, or Mistral's Lechat reasoning model, even those sophisticated models, when they're powered by Cerebras, become the fastest in industry by orders of magnitude. Models powered by our systems regularly output in thousands of tokens per second, delivering instant reasoning, instant conversational voice, and instant interactivity that, once again, we know from the history of the internet drives engagement, drives revenue, drives efficiency. So graphs are great, but let's take a look at what that X factor looks like for real model. So I'm going to click play on this video in just a moment. On the left, you'll see inference from Cerebras. On the right, you'll see inference from a state-of-the-art GPU implementation from a hyperscale web provider. Same model, same question. We're going to ask Llama 70B here for a list of 10 great computer scientists and tell them what was a significant finding from each. So we'll click play, Cerebras on the left, GPU on the right. We're done. All right. It really is cool, and then we have to buy ourselves some time, maybe grab an espresso and enjoy ourselves while the GPU systems finish. Right? We know what interactivity looks like. We know what instant answers look like, and now we can provide them. It's not just one model, though. It's every single model we bring up and power with Cerebras is the world's fastest, bar none. Few charts here showing Llama 4 Scout, Llama 3 370B, Llama 3 1 405, one of the largest models in industry, sophisticated reasoning models like DeepSeek. Every model we bring up is the fastest in industry. And there's more models coming today, and we'll have some announcements later about some of the latest models that our team is bringing up and making available to our partners. So now that I've convinced you that we're fast, you might be asking yourself, OK, I believe you. You showed me. But what about the value, right? What about the value to enterprise? What about the value to market? What about the value to science? You'll hear more about that later. But I think just very briefly, I want folks to think it's not just faster chat, right? I showed a cool chat example. But it's not just faster chat that speed unlocks. It's things like instant interactive reasoning, sophisticated models that answer quickly. It's engaging conversational voice. We all remember the first time we used a voice assistant and then chuckled with our friends because it took time to respond. And it was really latent, and you'd end up talking over each other, right? Let's just crack the code on that. Let's be done with that. Instant interactive multimodal generation, or agentic workflows, where one question from you opens up the door to a myriad of daughter agents that are performing tasks for you and returning responses instantly. Right? The world of productivity opens. And also opens the door to real-time physical AI, which is something that we're hearing more and more about as people start building on top of models for applications beyond language to AI applications that are driving things like robotics or the Waymo vehicles outside. Right? So speed here opens the door to GPU impossible applications that are quite literally foreclosed to developers today by what I like to think of as the artificial speed limits that have been placed on AI by legacy infrastructure. So speed here doesn't just drive faster chat, but it really opens the door to developers and thereby opens the door to new multi-billion-dollar markets. For customers like we have joining us here today, like AlphaSense, LiveKit, IBM, GSK, and others, this means better engagement. It means delight for your customers. And when you're running a business, it means efficiency and revenue. OK. So we talked for a few minutes about inference. Let's really quickly shift gears to training. That'll set the stage for our first guest coming out to tell us a little bit more about what they're building with Cerebras. On the training side, recall that inference was a memory bandwidth problem. Right? On the training side, it's not quite that simple. On the training side, the fundamental problem is one of distributed programming and distributed compute. And the fundamental challenge here is that sophisticated models today are simply too large to fit on one GPU. So if you're building a model, what you have to do is you have to take your model and you have to split it over tens or hundreds or even thousands of GPUs. And then you have to split up the compute. And then you have to split up the communication patterns. And then you have to figure out how to get all those hundreds or thousands of elements to work together. As I mentioned before, your cool AI model building project just turned into a massive supercomputer parallel programming project, right? And that adds technical requirements and drag on your engineering and research workforce that fundamentally limits their innovation velocity and their ability to build a cool new state-of-the-art model and bring it to market faster. Once again, we can do better. On Cerebras, we can unlock 10 times faster time to solution. That is, faster time to state-of-the-art models in days or weeks rather than weeks or months. And we can do this because even the largest models in existence today can be trained on a single Cerebras device. And thereby, when we want to train on, say, a cluster of hundreds of machines, the distribution problem is easy for our compiler to perform, and researchers can literally use the same AI frameworks, the same AI programming languages that they used in graduate school for a single desktop GPU, except they're now programming the world's most powerful AI supercomputers. And this allows them to iterate more quickly for models large and small, and iterate quickly as they scale up and down their compute resources. So, as a point of fact, over the past 12 months alone, our team and our customers have built more than a dozen state-of-the-art foundation models, right? Either new models from scratch or fine-tuned existing open-source foundation models for domain or industry or dataset-specific problems. For customers like Core 42 or GSK or the Mayo Clinic, who's also joining us here today, what that means is that their teams, along with our teams and our infrastructure, can build new state-of-the-art models, pre-training and fine-tuning, not in weeks or months, but in days or weeks. More rapidly iterating, building better models faster. So with that, I'll wrap up. And I'm going to hand over to our awesome partners, beginning with Chris Ackerson from AlphaSense. I just want to say thank you. This slide summarizes our technology, our position in the market as the platform for future AI. Feel free to grab a snapshot of that. But moreover, you're here with us today, so please feel free to find me, find our team afterward to learn more. So coming up next, we're going to have